Hi ladies, so we're going to go over a couple of examples before we take the quiz. You can follow along with me on your OneNote. So it said problems before the quiz in your OneNote under the PowerPoints, and it will have the example that I'm about to read up there so that you can reference while we're going over this video. So go ahead and open that up on your OneNotes, and then I'll go ahead and read it aloud. The amount of nitrogen oxides, NOx, present in the exhaust of a particular type of car varies from car to car according to a normal distribution with a mean of 1.4 grams per mile and standard deviation of 0.3 grams per mile. Two randomly selected cars of this type are tested. One has a 1.1 grams per mile of NOx, the other has a 1.9 grams per mile. The test station attendant finds the difference in emissions between the two cars surprising. If the NOx levels for the two randomly chosen cars of this type are independent, find the probability that the difference is at least as large as the value that the attendant observed. Follow the four-step process. So our main problem here is at least as large is definitely a problem. So at least as large is going to mean that I want to know how great that difference is in either direction. So I want to know how likely it is to be less than that difference and greater than that difference. I'll show you what I mean on the next slide. Okay, a difference of at least as large, right? So that's kind of a crazy concept. Again, let me talk about that. So I'm saying that my difference, it could be this, or my difference could be this. So what I'm talking about is really the difference in either directions. So either my difference is this, and I end up with a negative 0.8, or my difference is this, and I end up with a positive 0.8. So I want to know what is the idea that the difference is at least 0.8. So the difference is 0.8 in either direction, really. So I want to look at it in either direction. So I want to see, okay, what's the likelihood that it could get 0.8 or be larger than 0.8? Or what's the likelihood that it could be negative 0.8 or less than negative 0.8? So I want both of these things at the same time. So this is really, I'm looking at two sides. We would call this a two-sided test. I'm looking at two sides of the probabilities, not just one this time. So I'm going to have to find out what this side is here and add it to what this side is. Okay, so the state is, what is the probability that the difference between the NOx levels for the two randomly selected cars is at least 0.8 grams per mile? And then remember that I wanted as great as, so it could be 0.8, it could be greater than 0.8 or less than negative 0.8. So we need to look at both directions. Okay, so just so we have the same reference point, we're going to say car 1 is X, and that was 1.1. And we're going to say that car 2 is Y with a 1.9. Great, so our plan. So we have a normal distribution, and we need to find what the mean and the standard deviation are of our normal distribution once it's transformed. So we need to find the difference of X minus Y and the difference of Y minus X, right? Because we want to do it in either directions. So if I do X minus Y, we have a difference of negative 0.8, and then here we have a difference of 0.8. So essentially, that's the difference that we're looking for. We did that earlier, so you could see why we did that. And then I want to talk about the mean. So the mean of the difference is going to be my mean of what X should be minus my mean of what Y should be. Now the mean was given to us as 1.4. So both cars should have a mean of 1.4, and they should have a standard deviation of 0.3. So if I go 1.4, it's 1.4 minus 1.4, hey, guess what? It's 0. So my mean of my difference is 0. The standard deviation, however, I'm going to need to add my variance. So 0.3 squared plus 0.3 squared, take the square root of both sides, and I'm going to end up with a standard deviation of 0.4243. So I have a mean of 0, a standard deviation of 0.4243, and what I'm looking for is the probability that x minus y is going to be less than negative 0.8, and, big and there, the probability that y minus x is going to be greater than 0.8. So if I'm drawing a picture of that, again, like we did on the other screen, I would say that this is negative 0.8 and this is positive 0.8, and I am looking for both of these added together. Okay, so I'm going to write down the z-score. So my difference was 0.8 minus 0 divided by my standard deviation of 0.4243, and then I'm just going to use TEC. So using TEC, I'm going to say that this is my lower, in this particular case, was 0.8. My upper was infinity. My mean is 0, right? And my standard deviation is 0.4243. Okay, so then the other side is just the same thing. My lower is negative infinity. My upper is negative 0.8. My mean is 0. My standard deviation is 0.4243. So when I find this using TEC, I'm going to find that this is 0.02968 and this is 0.02968. So when I add them both together, I get an answer of a total probability of 0.05936. Okay, so the conclude for this says there is only about a 6% chance of randomly finding two cars with as big a difference in NOx levels as the attendant found. So then there's our conclusion in full context. The last problem I wanted to quickly go over dealt with a problem that you probably saw in the sapling last night that might have stumped you. A study of working couples measures the income X of the husband and the income Y of the wife in a large number of apparently heterosexual couples in which both partners are employed. Suppose that you knew the means mu sub X and mu sub Y and the variances sigma sub X and sigma sub Y of both variables in the population. A, is it reasonable to take the mean of the total income X plus Y equals mu sub X plus mu sub Y? Explain your answer. The answer is yes. The mean of a sum is always equal to the sum of the two means together. So we're good. That one's fine. B, is it reasonable to take the variance of the total income to be the variance of X plus the variance of Y? Explain your answer. The answer to this is no, because the variances of the sum is only equal to the sum of the variance when X and Y are independent. So I can total up the sums and have them not be independent, but I can't do that for the variability. So we can't assume that there's not some impact of X on variable Y or Y on variable X. These incomes may be related, especially since they're a couple. So we cannot say that they're independent. And that's it. You are now ready to take your quiz. You got this, ladies.